Dear students, here is a question of numerical methods. Find out the root of the following equation using Regula Falsi method. Function is x e to the power x minus cos x equals to 0. That lies between 0 and 1. That means the root lies between 0 and 1. Correct to 4 decimal places. Let us start. The function given fx equals to x e to the power x minus cos x, and the interval given between 0 to 1. So let us see what is the functional value at 0. 0 e to the power 0 is 1, 0 into 1 is 0, minus cos 0, that is minus 1. And the functional value at x equals to 1, that is 1 e to the power 1 minus cos 1. If you find by calculator, you will get the value as 2.17798. So look here, f0 is negative and f1 is positive. So according to the theorem, there exists a root in between 0 and 1. Now the general formula of Regula Falsi is xn plus 1 equals to xn minus f of xn divided by f of xn minus f of xn minus 1 multiplied by xn minus xn minus 1. Now for x equals to 1, for n equals to 1, put n equals to 1 in this equation, then x2 equals to x1 minus f of x1 divided by f of x1 minus f of x0 multiplied by x1 minus x0. Now what is the values of x1 and x0? Let us take 0 as x0 and 1 as x1. Then let us put the value of x1, that is 1, minus f of x1 is already found, that is 2.1778 divided by 2.1778 minus 1 and 1 minus 0. By calculating, you will find 0.6853335. So what is the functional value at x2? So f of x2 is, if you put in the equation x2 e to the power x2 minus cos of x2 as 0.685335, then you will get the value 0.5857797. Now let us make a table. Number of iterations, xn minus 1, xn, f of xn minus 1, f of xn, xn plus 1, and f of xn plus 1. So for first iterations, iteration number 1, the value of xn minus 1, that is n is 1, 1 minus 1 is x0 is 0 and x1 is 1. So this is 0 and x1 is 1, and the functional value for x0 it is minus 1, and for 1 it is 2.17798, and x2 we have got 0.685335. So this is x2 685,335, and the functional value we have got 0.585797. Now look, the functional value is positive. So here f of xn, the functional value is positive. This positive value will be replaced by this. So for iteration number 2, 0 will remain as it is, and instead of 1 we'll have 0.685335, 0.685335, and for 0 functional value is already minus 1, and for 0.685335 the functional value is 0.585797. Then you have to find x3. So from the formula, again showing this, that if you put n equals to 2 here, then you will get x3 as x2 minus f of x2 divided by f of x2 minus f of x1, and this is x2 minus x1. So what is x2? x2 is 0.685335 minus the functional value is 0.585797 divided by, this is f of x to 0.585797 minus the functional value f of x1 was 2.17798, and this one will be, for 0 it is minus 1, because 0 will be the x1 in this case, and x2 is 0.685335 and x1 is 0. So you will have the value 0.43 by calculator, find out it, 0.432171, and for 0.432171 the functional value is, x3, this one, x3 e power x3 minus cos of x3. So for x 3.432171. If you put in this equation, you will get the functional value minus 0.242256. Now you put this value in the table, that 0.432171 here, 0.432171, and the functional value is minus 0.242256. So in this way you will proceed few iterations, 3, 4, 5, and then at last when you will find that 2 iterations value are same, then you will get the result. In this case you have to find up to 8th iteration, and you will notice that the 7th iteration, that is x8, and the 8th iteration, that is x9, you will get the value as same, and that value is 0.517757, which is the required root. Hope you have understood.